Hello everyone, today we're going to look at usaco-training Agri-Net. Okay, so in this problem we're given n farms, and then we're given an connectivity matrix where each element represents the cost from one farm to another. So then, for example, the first row means the distance from farm 1 because it's the first row to any other farm. For example, here, this 4, since it is in row 1, column 2, it is the distance from farm 1 to farm 2. And let's just say for the last row, if you see this element, this means that it takes 16 units of distance to get from the fourth farm to the third farm. Okay, so originally all the farms are not connected, and we can choose to use some of these edges to make them connected. And then we're going to print the minimum number of fiber to connect the entire set. So then let's just say we use this edge, that means that we're taking a cost of 9. Okay. Whoops. Okay, so we can basically label the farms at nodes. So we have 4 nodes, so we would have 1, we have 2, we have 3, and then we have 4. So we can actually create an edge between those two nodes. So for example, the distance between 1 and 2 is 4. The distance between 1 and 3 is 9. And the distance from 1 to 4 is 21. Okay, the distance from 2 to 3 is 2 to 3 is 8. So then let's just draw another one. This is 8. And the distance from 2 to 4, in this case, is 17. And the distance from 3 to 4 is going to be 16. Okay, so this is our graph, and we can just use the adjacency matrix to make this. So then, what we're going to do is that we're going to run the minimum spanning tree algorithm on this. So we can basically label each edge or each node as if we already added to a connected component. So originally, you can say that the first barn is done, so you mark that as done. And then what we're going to do next is that we're going to basically activate these edges. So then we're going to activate this, and this. Okay. So then, once we activated this, after we see farm 1, we're going to see the next farm that has the least edge. So in this example, you would take 4 because it is the edge with the least cost, since here it has 9 and here it has 21. Okay. So then, after we see that we're going to take this edge, we're going to mark this as done since we connected these two components. So then we activate this edge, and then we activate this edge. Okay. And then right now, our edges would be, let's label in red, we have this edge, we have this edge, this edge, this edge, and that's it. So then we would take the edge with length 8. So then we would take this one, and then we would mark this as done. Okay. So after this, when we mark this one as done, we're going to activate more edges. So we're going to activate this edge as well. So right now, you see that the edge with the minimum cost is this one. But actually, since making a new edge from 1 to 3 is basically useless because 1 is already in the component, so we don't take it. So then our best edge would be taking the one with length 16. Because 4 is the only node that's not connected, and there's an edge with minimum weight. Since, as you can see, this 17 is not as small as 16. So then our answer will just be the sum of the edges we used. So then we're going to take this, this, and this. So our answer would be 4 plus 8 plus 16, and this would result in 28, which is our desired result. Okay, so this is Agri-Net. Okay, so let's include bits. Okay, so we're going to take in the number of nodes, so we can call this n. And then we're going to be given an adjacency matrix. So let's call this A. And the maximum n is going to be 100, so we can just do 105. Okay, so now we're going to read in our matrix. So let's read it. Okay, so let's read in A of I of j. Okay, so now we're done reading that. We're going to run the minimum spanning tree. So first thing we're going to do is that we're going to have an array keeping track of okay, so let me just go back. So if we're going to activate an edge, we know that we're actually activating the node that's behind the edge. So we can actually have that node indexed as the cost of that edge. So we can call this weight. Okay, so you know that originally all the weight would be equal to infinite, meaning that you cannot take it. So weight of I will be equal to, let's call this one 9. Okay, so now we can just set weight of 1 to 1, or actually 0. Okay, so now we're going to keep track of what we have so far. So right now we have to know our node, so let's call this int cur. Originally it would be equal to 1. Okay, so now we loop through, we actually have to add an edge n minus 1 times. So then we can do for int I equals 1. Okay, so we picked out our cur already. So what we're going to do first is we're going to activate those edges. So for int j equals to 1, so we're going to activate this. So the weight of j would be equal to the min, because you want the minimum weight, and the cost of this, which is going to be a of cur of j. Okay. So then, after we activated this, we're going to choose which edge we're going to use now. So then, again, we loop through all the other nodes. Okay. So we can basically mark a node as done if it's visited. So we can have a visited, or if we connected this node before. So then visited I would be equal to 0, since originally all the nodes would be equal. It would not be visited. And here's the case. So visited of 1 would actually be equal to 1, since we're going to start from 1 and we're going to expand the tree. So then over here, we can call this int next. Let's call this -1. Okay, so if this is not visited, if not visited j, and if either next is equal to -1 or the weight of j is less than next, or weight of next, then next would be equal to j. So next thing we need to do is just set cur to next. Okay. So now basically we know that we're going to take this edge, so we actually have to add the weight of this edge to our answer. So let's call this int answer. So over here, we're just going to increment our answer by the edge, or the weight of the edge we've chosen. So this would be next. So we just print our answer in the end. Okay, this is usaco-training. and Agri-Net. Okay. Okay, it's compiling. Okay, so 4, which is not correct. Okay, oh yeah. Okay, so over here, when we have our current, we're actually going to mark the current as true because not only we mark one as true, every time we add a new edge, we actually mark it as true. So this actually should be over here. So visited of next, because we know that we added this, which means that it's in a component already. So then again, we run it. Okay. 28, which is right. So I'm just going to submit it. Okay, so this is Agri-Net.in, and this is Agri-Net out. Okay, and this is C++11. Okay, so let's submit it. Okay, usaco-training Agri-Net. Okay, so here and here. Okay, so that is right. If you have any questions, feel free to leave them in the comment section below. Bye.